Hello, today we're going to be learning about inverse functions. And rational functions. Our whole unit is rational functions. Before we do so, we have to learn the equations of each of these lines. Now this green line going across is at 1, 2, 3, 4 up, so that equation is just going to be y equals 4. The blue equation is a horizontal line at negative 1, so we'll write y equals negative 1. However, this vertical line is at 1, 2, 3, 4, 5, and this is where x is going to be 5. So we write this equation x equals 5. So vertical lines we write as an equation x equals. Horizontal lines we write y equals. What type of an equation is this? What kind of function is this? Hopefully everyone is saying exponential. Now what are the equations of the asymptote? The asymptote is this line that is getting closer and closer to, but never actually hits. This one right here. And that's a horizontal line at 2. So y equals 2. Now let's talk about the domain and range of this function. The domain goes from negative infinity all the way up to infinity. The range starts at 2 and goes towards infinity, but doesn't touch 2. So we go from 2 to infinity. Alright, what type of equation is this? Hopefully you're saying inverse power. What are the equations of the asymptotes? Well, now there's two. There's one vertically, and that is going to be x equals 0. There's one horizontally, and that is going to be the one y equals 0. Now the domain of this function is from negative infinity all the way up to 0, not including 0, and then that's a union with 0 to infinity. Now my range is going to be the same thing. It goes from negative infinity to 0, not including 0, and then goes from 0 to infinity, not including 0. Alright, what type of function is this? This is again an inverse power. The equations of the asymptotes will be the exact same. They're the two lines, so x equals 0, y equals 0. Here the domain is the same as the previous problem. And my range now just goes from 0 to infinity, but not including 0, and of course not including infinity. Now, let's look at the, I'm going to get rid of this for a second. The actual equation that we'll use here is, y is equal to 1 over x squared. That is what this looks like. This previous one is y equals 1 over x. These are very important equations for this chapter, and I'm going to expect that you have them memorized. So if you don't know what they look like, you have to memorize them now. Alright. Now, if we look at this, we're going to take the 1 over x graph, and what does this transformation do? Hopefully you're saying move it up 2. So if I drew this out real quick, we'd have our asymptotes, and then it would come, it'd be our 1 over x graph. It looks like so. So the equation of the asymptotes, the horizontal one would be y equals 2. My vertical one will still be x equals 0. Oh, and I already sketched the graph. I was ahead of myself. Alright, now describe this transformation. X plus 5. What direction does that move it? Hopefully you're saying move it to the left 5. So I like to sketch the graph before I make the equations of my asymptotes. So if we move it to the left 5, we have our vertical line, we have our horizontal line, it's 1 over x. I'll do this in a different color just so it's a little bit more clear. It'll go out like that, and like that. So my equations of the asymptotes are x equals negative 5 and y equals 0. All right, describe this transformation. The x plus 3 is going to move it to the right 3. That negative 1 is going to flip over the x-axis. So let's draw this. Now, this is not, first off, it's not the line I intended to draw. Second off, this is not a 1 over x graph. It's a 1 over x squared because it has that squared up there. So we're going to move it to the right 3. And now instead of drawing the 1 over x up here, we're going to flip it over the x-axis. So it looks something like this. Those should be arrows. So now if we want to find the equations of the asymptotes, x equals 3, and then y equals 0. All right, try this one. This transformation moves it up 5. Equations of the asymptotes are going to be at, y equals 5, and x equals 0, and it's going to be x squared, so it's going to come down from the top and go towards my asymptote. Hopefully you're getting familiar with this. Now if I wanted to do this, graph this, I don't know exactly where this one goes. It's a little confusing. So what we need to do is polynomial division. X plus 2 into 3x plus 8. This goes in 3 times, and when I subtract out, I get a 2. So this is equal to 3 plus 2 over x plus 2. So what that does is the x plus 2 is going to move it to the left 2. The plus 3 is going to move it up 3. So now I can draw my asymptotes in like so. And this is a 1 over x graph. So it's going to start up here and then look something like this. Now you might be wondering what that 2 does up here. And what that does is it's a vertical stretch, and so it pulls it away from these axes. And it's hard to actually see exactly where that's at. So in your sketch, it's not going to be critical yet. A bigger number would pull it out further like that. All right, now try this and see if you can do this one on your own. All right, hopefully you're done. If we put x plus 5 into 4x plus 1, that would go in 4 times. So this would be y equals 4 plus, that is a minus 19. So 4 minus 19 over x plus 5. So if I drew this out, we'd go up 4, 1, 2, 3, 4. Then we move to the left 5, 1, 2, 3, 4, 5. Let's draw some lines in here. Now, the negative, instead of going upper right, lower left, we'll flip that over this horizontal axis. Now the 19 is going to pull it really far from the axes. It's still not going to cross this line, but then it's going to keep going and get closer and closer to this one, but never actually touch it. All right. Now this one gets a little weird with our division, because we have 3x plus 8 on the outside, x plus 2 on the inside, so what times 3 is going to give us 1? That's 1/3. So that would be x. This would be 8/3. And when I subtract, 2 minus 2 1/3 would be negative 2/3. So this would be 1/3 minus 2/3 over 3x plus 8. Now this isn't the best way to write this. This is really 2/3 divided by 3x plus 8, which is the same thing as 2/3 times 1 over 3x plus 8. So that's 1/3 minus 2 over, this would be 9x plus 24. That's kind of weird. Let's take a look at this. So if this is our function, it goes up 1/3. Now, what is going to make that 0? If 9x plus 24 equals 0, 9x will be negative 24. So x will be negative 24 ninths. Now, 3 can divide into both those, so that's negative 8/3. That's going to be my value for x. And it would have been easier to just see that that's negative 8/3 there. So negative 8/3 is negative 2 1/3. Negative 2 2/3, I should say. So there's going to be an asymptote here. There's going to be an asymptote at 1/3. And it's going to be negative, so it's going to come up like this, come out to the right, or come out to the left, and then it's going to go out to the right like so. Alright. Kind of a weird problem. Now, this next problem is a little bit different. It says write an inverse square function that has asymptotes at x equals, or y equals 3, x equals 2, and passes through the point 3, 12.5. So I like to draw this out, give myself a visual of what's actually happening. X equals 3, or y equals 3, x equals 2. And then it passes through 3, 12.5. So 3, 12.5 would be up pretty far. Let's put it up there. Now, my equation, so it's y equals 3, it should be 3 out front, plus, if it passes through 2, it should be x minus 2 down here. Now we need to figure out what will go there, so that's 3 and 12.5. So let's just put an a there, and plug in my x and my y. So my y value is 12.5. I don't know my a, but my x is 3. 3 minus 2 is 1, so a over 1 is just a. So 3 plus a is 12.5. So if we subtract 3, 9.5 is going to be our a value. So my equation in this situation is y equals 3 plus 9.5 over x minus 2. Alright, that's my rational equation. So you have a worksheet for tonight.